Hello, this is our last topic for statistics. We're analyzing and simulations and doing confidence testing. So basically, confidence testing is how confident are you that this data is significant. It's also called significance testing. Is this a significant result? So the radio station claims to advertisers that the average number of minutes that commuters listen to the station is 30 minutes. The station conducted a survey of 500 of the listeners, so this is a sampling of population of people who actually listen. They don't mention how many people are going to be in this population, how many people are actually listening. But they did a survey of 500 people. So the actual average of those 500 people was 29.11. Oh no, it's a little below 30. Are they lying? Well, that's why we do the test here. Is that significantly below 30 to make them change their claims? Or is it close enough that they can claim that the average number is 30, or maybe they should say about 30. So they did a stimulation, run 1,000 times. So this is just a computer simulation based on the data from their survey. So that it averaged out to 29 minutes. And then you have your standard deviation here. You're going to deviate from that mean on average quite a bit, but how much? So our standard deviation is 0.9, so almost 1. So if you go 2 up, that's 31. If you go 2 down, that's 27. So previously I added this exactly, and that's down below. You can read that. So 2 standard deviations should represent 95% of the data. So if they claim that there was 30, average person listened 30 minutes and the actual average was 27, then that would be significant. Or if they claim that the average was 32 and this is the results, they would have to change that to 29 or 30. They could actually do 30.5 and that would still fall within 95%. So when you're doing confidence testing, significance testing, you want to just find 95% of the data. And when you have a bell-shaped curve, all you got to do is look at where it's the biggest. So when it starts to get really small, that's probably out of your 95%. So this up here, about 2.5%. This on the top, about 2.5%. So our range of data is 27 to 30.97, so almost 31 if you round it up. So yes, 30 minutes is plausible because that's within this 2 standard deviations. That's part of the 95 percentile. So if you surveyed a different group of people, if you did enough surveys with 500, one of those would come out almost exactly to 30, or it might come out even more than 30 minutes. So that would be fine. So that's what we're going to be looking for in these next couple of examples. Is we're going to see if it falls within 95%. So we're going to calculate the 95 percentiles and then see if it's significant. So what I'm going to go over now is 19 through 22 or 23. So these are the questions that have to do with the notes that I just recorded. If I have time at the end, I will go over questions, like 15 through 18, whatever questions I wasn't able to get to on my last video. I'll just try to throw the answers up there or go over whatever ones I deem most difficult. If I run out of time, maybe I'll try to do another video for that. So number 19, Elizabeth waited 6 minutes for fast food. She was upset having to wait so long. So the manager said her experience was very unusual, so out of the norm. So we'd expect that to be out of 95%. So they did a survey, and they said it was 226 seconds, and the standard deviation was 38 seconds. So what we're going to do here is we're going to take 226, that's going to be our middle. We're going to add and subtract 2 standard deviations, and we're going to see if 6 minutes is within that. If it is, then that could be a common occurrence and the manager could be lying. If that is outside of the 95%, then we're going to say yes, he's right, that is unusual, but obviously 5% of the time that's going to happen, which is pretty rare. So if she comes back again, it's very rare she'll have to wait that long. So let's do the work and check back in. So 6 minutes is 360 seconds. So I took my average for the sampling was 226 seconds, plus or minus 2 standard deviations. So each standard deviation was 38 seconds. You double that, you get 76. So you're adding 76 seconds to find the top end of the 95 percentile, and then you're subtracting that number to find the lower end of what's expected in a normal situation. So in a normal situation, or 95% of the situations, if this follows a normal bell-shaped curve, is from 150 seconds to 302 seconds. So the top end of our 95% confidence interval, the top end of what we'd expect to happen 95% of the time or more, is about 5 minutes, and the lower end is a little bit more than 2 minutes, right? 2.5 minutes is what we would expect on the lower end. So yes, this is unusual. The manager is correct by saying this is very unusual. We'd only expect this to happen in 2 to 2.5% of the cases. That would be over 6 minutes. Under normal conditions. I mean, if people just let out of a football game, or there's a parade in town or something, then of course you're not going to have a normal bell-shaped curve, and everything could be off. Next example. Mary bought a pack of candy. The manufacturer claims that 30% of the candies manufactured are red in her pack. So this is a sample. Well, not a sample, but this is one example. In her pack, 14 of the 60 candies are red. She ran a simulation of 300 samples. Assuming the manufacturer is correct, the results are shown below. So I'm going to scroll down in a second. So what did she find? 14 out of 60 is about 23%. So is that within 95%? It seems pretty close. Maybe a little bit low. Doesn't seem like it'd be terribly out of the ordinary, but maybe a little bit on the low end. So we're going to find this 95% using our mean of 0.301 from our simulation, and we're going to add and subtract 2 standard deviations. So in this case, the number we're comparing is going to be below, so we're going to be more concerned with subtracting 2 standard deviations from this, but we'll see. So my final conclusion is going to be that Mary's pack had 14 out of 60 candies. I got 0.233, so that's 23.3% instead of the normal 30%. Is that way below normal, way below the average? Well, when we do the 95% confidence interval, the top end is 41.7%. The bottom end, 2 standard deviations below, is going to be 18.5%. So this is not unusual. This is not some strange happenstance. It's perfectly normal based on my sampling that this should happen. If candy manufacturer doesn't want this to happen, then maybe they should have stricter guidelines. But this is on average what does happen. So obviously the further out you get, the more abnormal it is to find this. So most of what we have here is about 24% to 36% is what your red candy should be. And she got 23%, so maybe a little bit below average, but it's still within the 95%. So that's a normal result, not abnormal, not significant. Okay, next problem. Okay, problem number 21. Robin flips a coin 100 times and lands up 43 times. So it's 43% of the time. She wonders if the coin is unfair because she found out in school that it should be 50%. So this is the difference between theoretical probability and empirical probability. Theoretical probability is what should happen. On average, it should be 50%. What actually happens is it's going to be a little bit below, a little bit above 50%, depending on how many times you flip your coin. But if you were to do it, 750 times, you were to flip it 100 times, so that's thousands of times of flipping coins, you would average approximately 50%. Here, the computer simulation averaged 49.9%, basically 50%. So the results of simulations provide strong evidence that Robin's coin is unfair? No. She's within, that coin is within 95%. The lower bound is about 40.1%. She had 43%. So she's a little low, but it's perfectly normal. If you flip it a certain way, sometimes you get the different kinds of results. So that is normal. Seems to be a fair coin. Okay, question number 22. It's pretty straightforward. You have to find the interval that contains the 95% of the data. So all we got to do is find the mean, 0.254, standard deviation, 0.060. Add 2 of those, subtract 2 of those, and you get an interval of 0.34 to 0.374. So between 13.4% and 37.4% is the normal results. This is question number 23. I'm not sure if I actually assigned this or not in the end. But this is a margin of error, and we're just kind of guesstimating this. I'm looking to see maybe where 95% of the data is. So I'm looking at about 0.52 to 0.58. So the margin of error is plus and minus the 2 standard deviations. So all I got to do is find 2 standard deviations. So 0.58 minus 0.55 is about 0.03. So I'm going with answer number 2. And so that would be 2 standard deviations up. So you would think that you could be off by that much. Okay, and that concludes my 3rd video for statistics. Bye-bye.